Hello everyone, welcome to the Microsoft Azure Networking video series. In this fourth video, I'll try to explain to you about the Azure VNet peering, VNet to VNet connection, site-to-site VPN connection, and express route. My name is Önder Değer. I'm a Microsoft Azure MVP and I work as an Azure Solution Architect. VNet peering is the simplest and quickest way to connect your virtual networks. Virtual network peering enables you to seamlessly connect two Azure virtual networks. Once paired, the virtual networks appear as one for connectivity purposes. There are two types of the VNet peering. Regional VNet peering connects the Azure virtual networks in the same region. Global VNet peering connects the Azure virtual networks in different regions. When creating a global peering, the paired virtual networks can exist in any Azure public cloud region or China cloud regions, but not in government cloud regions. You can only pair virtual networks in the same region in Azure government cloud regions. Network traffic between paired virtual network is private. Traffic between the virtual networks is kept on the Microsoft backbone network. No public internet, gateways, or encryption is required in the communication between the virtual network. A low latency, high bandwidth connection between resources in the different virtual networks. The ability for resources in one virtual network to communicate with the resources in a different virtual network once the virtual networks are paired. When virtual networks are paired, you can configure a VPN gateway in the paired virtual network as a transit point. In this case, a paired virtual network can use the remote gateway to gain access to other resources. A virtual network can only have one gateway. Gateway transit is support for both VNet peering and global VNet peering. VNet peering is non-transitive. This means that if you establish VNet peering between VNet 1 and VNet 2 and between VNet 2 and VNet 3, VNet peering capabilities do not apply between VNet 1 and VNet 3. However, you can leverage user-defined routes and service chaining to implement custom routing that will provide transitivity. You can deploy hub and spoke networks, where the hub virtual networks can host infrastructure components such as network virtual appliance or VPN gateway. All the spoke virtual networks can then pair with the hub virtual network. Traffic can flow through the network virtual appliance or VPN gateways in the hub virtual network. You can connect your VNets with a VNet to VNet VPN connection. Using this connection method, you create a VPN gateway in each virtual network. A secure tunnel using IPsec IKE provides the communication between the networks. With a VNet to VNet connection, your VNets can be in the same or the different regions, in the same or the different subscriptions, in the same or the different deployment models, in Azure or on-premises. A VPN gateway is a specific type of the virtual network gateway that is used to send the encrypted traffic between an Azure virtual network and an on-premise locations over the public internet. You can also use a VPN gateway to send the encrypted traffic between Azure virtual networks over the Microsoft network. Each virtual network can only have one VPN gateway. However, you can create multiple connections to the same VPN gateway. When you create a multiple connection to the same VPN gateway, all VPN tunnels share the available gateway bandwidth. When you create the virtual network gateway for a VPN gateway configuration, you must specify a VPN type. The VPN type that you choose depends on the connection topology that you want to create. For example, a point-to-site connection requires a route-based VPN type. A VPN type can also depend on the hardware that you are using. Site-to-site configuration require a VPN device. Some VPN devices only support a certain VPN type. A VPN type you select must satisfy all the connection requirements for the solution you want to create. For example, if you want to create a site-to-site VPN gateway connection and a point-to-site VPN gateway connection for the same virtual network, you would use a VPN type route-based because point-to-site requires a route-based VPN type. You would also need to verify that your VPN device supported a route-based VPN connection. There are two VPN types. Policy-based VPNs. Policy-based VPNs encrypt and direct packets through IPsec tunnels based on the IPsec policies configured with the combinations of address prefixes between your on-premise network and the Azure VNet. The policy is usually defined as an access list in the VPN device configuration. Route-based VPN use routes in the IP forwarding or routing table to direct packets into their corresponding tunnel interface. The tunnel interface then encrypt or decrypt the packets in and out of the tunnels. The policy for route-based VPNs are configured as any to any. When you create a virtual network gateway, you need to specify the gateway SKU that you want to use. Select the SKU that satisfy your requirements based on types of the workloads, throughputs, features, and SLAs. Aggregate throughput benchmark is based on the measurement of multiple tunnels aggregated through a single gateway. The aggregate throughput benchmark for a VPN gateway is site-to-site and point-to-site combined. The aggregate throughput benchmark is not a guaranteed throughput due to internet traffic conditions and your application behavior. These connections limits are separate. For example, you can have 128 SSTP connections and also 250 IK version 2 connections on a VPN Gateway version 1 SKU. The local network gateway typically refers to the on-premise location. You give the site a name by which Azure can refer to it, then specify the IP addresses of the on-premise VPN device for the connection. You can also specify the IP addresses prefix that will be routed through the VPN gateway to the VPN device. The address prefixes you specify are the prefixes located in the on-premises network. Azure Express routes let you extend your on-premise network into the Microsoft Cloud over a dedicated private connection facilitated by a connectivity provider. With the Express route, you can establish connection to Microsoft Cloud services such as Microsoft Azure, Office 365, and the CRM Online. Use Azure Express route to create a private connection between Azure data center and infrastructure on your premises or in a colocation environment. Express route connections don't go over the public internet, and they offer more reliability, faster speeds, and lower latencies than the typical internet connection. In some cases, using express route connections to transfer data between on-premises system and Azure can give you significant cost benefits. With the express route, establish connections to Azure at an express route location, such as an exchange provider facility, or directly connect to the Azure from your existing WAN network, such as the multi-protocol label switching VPN provided by a network service provider. Express routes give you a fast and reliable connection to Azure with bandwidths up to 100 gigs, which makes it excellent for scenarios like periodic data migration, replication for business continuity, disaster recovery, and other high availability strategies. It can be a cost-effective option for transferring large amount of data, such as datasets for high-performance computing applications, or moving large virtual machines between your dev test environment in an Azure Virtual Private Cloud and your on-premise production environment. Okay, our VNet gateway is completed. So let's go to our resource group. As you can see, I have one virtual network gateway in my on-premises resource group, and I have one public IP address, and this public IP address is attached to my on-premise virtual network gateway. So in my another resource group, I created two virtual network gateway, and it's already configured in here. So let's try to connect to VNet to VNet. So I'm going to connections and click add. I would like to connect to VNet to VNet. So if you would like to create a VNet to or site-to-site VPN, you can choose the site-to-site VPN, but when you go to site-to-site VPN, you have to create before local network gateway, and in this local network gateway you have to define your on-premise VPN public IP address and on-premise IP address range, and after that you can use this one. But for now we're gonna use VNet to VNet. So let's say under, or let's say VNet to VNet. And my second virtual network gateway I have already created, which is my on-premise VNet gateway, and I'm gonna use pre-shared key for now. Of course, I recommend use the complex one, and I'm gonna use the iKey version 2. This is my resource group, and I will say create. Okay, my connection added. As you can see, added, but it's still not connected. So I have to go back to my on-premise virtual network gateway, and I have to create a connection from on-premise to VNet 1. So let's say VNet to VNet, and my second virtual network is VNet 1, and this is my pre-shared key. I have to use the same pre-shared key, and let's say okay. So in a couple seconds this connection status must be changed connected, so let's little wait. Yes, it's connected now, as you can see. Let's look at the first one. On-premise virtual network gateway from on-premise virtual network gateway to VNet 1 virtual network gateway is connected. I mean East US to North Europe is connected. And the second one from virtual network 1 to on-premise virtual network is connected to, I mean North Europe to East US. So VNet to VNet configuration finish, so we can use this connection to our production environment or every kind of environment. But as you can see, the VNet to VNet configuration is a little bit harder than the VNet peering configuration, and I can confess easily VNet peering is more reliable and is easy to configure and easy to set up. So of course when you go to VNet configuration, you will use encryption or the other methodology, but peering is still, I can say peering is still secure because it's working over the Microsoft backbones. And thank you for watching my video, and you can follow me on LinkedIn or Twitter, or you can reach me out on my blog's website, which is the devcloudops.com, and see you in the next video.